Hello guys, and welcome back to my channel. So in this video, I'm going to reduce the rate of solar fire by 20%. You see, this is another case of solar fire. It happened a few days ago. You see, one thing that I don't like, one thing I hate as a solar installer is solar fire. The increase of rate of solar fire these days, it is so alarming. So I'm on a mission to stop solar fire. You see, my first video reduced the rate of solar fire by 10%, and this video I'm going to reduce this rate of solar fire by 20%. Okay, you don't know how, you don't just want to get yourself involved in it because you don't know how embarrassing it is as a solar installer to be involved in a solar fire. Firstly, the customer will lose total confidence in you and you may go to jail. Okay, so I'm going to reduce the rate of solar fire, and I'm going to use this topic, which is cable sizing, a very simple topic that 78.5% of solar installers know. That is my personal statistics. A lot of solar electricians know this cable sizing. They know how to calculate this power formula. Power equals to IV, which is very common among solar installers. But they don't understand the real life application of this formula. They don't know how it's applied. They just calculate P equals to IV, and they just use this formula to sort their cables. You know, I will teach you how to apply this formula in real life, in practical terms. Okay, you see, one thing about our educational system, the failure of our educational system in my continent is the abstraction of our educational system, the abstraction of the system, the encapsulation of the system. You see, there are a lot of graduates that cannot even install a 3-gang switch. You see, it's not their fault, it's because they always find S. They memorize formulas, and at the end of the day, they cannot apply it to real life scenarios. So one thing I believe in, show me the formula and teach me how it is applied. Okay, so enough of the long talks. The size of a cable is a determinant of current and voltage. Like the current and voltage determines the capacity or current carrying capacity of a cable. Okay, so if you want to buy a cable for any solar system, you should know the current carrying capacity or the voltage. But specifically, we should know the current. If you know the current rating of the system, then you'll be able to appropriate your cables. Okay, be able to do the proper cable sizing. Okay, so let's go. Now let me give you a simple example. Now look at it. If, for instance, you have your laptop here. This is your laptop. You have your laptop, and you have your laptop charger. Okay, this is the adapter, and this adapter is 40 watts, and it's connected to a source of power, which is your socket. Now it's connected to the source of power, which is your socket, and it's connected to your laptop. Now take note, there are two nodes here. Okay, you can see it clearly. Now there are two nodes here. You can see there are two sides of cable, two cables here. There are two cables here, one here, and the one that is being connected to the 240 volt source of power. Now you should know that the current is flowing through the cables. In solar system, anywhere you see cable, calculate. Okay, in solar system, any solar setup, anywhere you see cables, calculate. Now you do your power formula. This is what's it called? This is a cable here, and this is also another cable. Now we want to know the amount of current that is being drawn, that is flowing through this cable, that is flowing from these sockets to the charger. Okay, we don't know the current that is flowing through to the charger because it is a cable. We assume that this system does not have a cable. So we want to know the current that is flowing into this charger. So if we know the current that is flowing to the charger and to the system, we'll be able to determine the cable sizes. Okay, so let me give an instance. Let's say this charger here is 40 watts, and this 40 watts is drawing 40 watts through the system. We know the power formula, which is power equals to current times voltage. And this is our charger here. We don't know the current that is flowing through the cable. Okay, but we know the power. Okay, now this 40 watt charger, as a 40 watt charger, it is drawing 40 watts. So the power here is 40, which is P. We don't know the current. Then we don't know the voltage. Now, what about the voltage? Now look at it. Since you are drawing 240 watts from here, and this is a 240 volt system, so 240 volt is flowing along with the power to this system. Okay, so we are drawing 240 because it is alternating current that is flowing from here. This place is 240 volt. The voltage from your house 240. Okay, from your grid and your generator is 240. Okay, so you are taking 240 volt from here to the charger. So the voltage is 240. Okay. You understand that? Good. The voltage is 240, and the voltage is flowing to the cable. So we have 40 watts and what? And 240 volts flowing to the cable. So if you are going to calculate your current, if you are using this formula, this P equals to IV, make I the subject of the formula. P equals to IV. You are going to make I the subject of the formula. I becomes power over voltage. Now, which is power is 40 watts. 40 over 240. This is 40 over 240, which is 0.16 amps. So the current that is flowing from here to the charger is 0.16 amp. Do you understand? So we use this current P equals to IV. We know the power. We know the power that is flowing through the cable, which is 40 watts, and the voltage is 240. So 40 over 240 divided by 240 is the current, which is 0.16. Okay. Now, let us okay, that is the current. We already know that the current that is flowing through here. Look at this. Whenever you see cable in any system, when you see cable in electric in a solar setup, do your calculation. If you see any cable here, you calculate for current. You calculate for current. You see, one mistake solar electricians make or solar installers make is they just calculate this power equals to current and voltage and apply it to every section of the system, and which is very wrong. If you are going to calculate the current that is flowing from this socket to the charger, you should be able to calculate the current also from the charger to your laptop. Okay, let's calculate the voltage and let's calculate the current that is flowing to your laptop now. Let's calculate this current that is flowing to your laptop. Now, we already calculated this current here that is flowing here as a 0.16 according to the power formula. Okay, we gave a formula here which is 0.16. Okay, now let's also apply the same formula. Anywhere you see cable in a solar setup, apply that power formula to calculate the current, and then you'll be able to size your cables. Now, we're also going to calculate the current here. Current equals to power over voltage. Now take note, this is a 40 watts charger. Okay, 40 watts charger. It is sending 40 watts to the system because the system needs 40 watts. Okay, so it's sending the current that is flowing through this cable is 40 watts. Do you understand? Because 40 watts is flowing to the cable. But this charger here converts the voltage and the current that is coming from here. It converts it to a DC because your laptop needs, let's say it needs 12 volts. Okay, it needs 12 volt to function, 12 volt DC to function. So this is what's it called here? This is your charger here. It converts the voltage and anything that's coming from here, it converts it to DC, which is 12 volts. So it is 12 volts that is flowing through this cable. Okay, so 12 volt is flowing through this cable. We already know that 12 volt is not 240 volts because this is your charger. That is the mistake a lot of solar stations are always making. The mistake solar stations make is they just calculate P equals to IV and that is all. You calculate power or your current in every section of the system. Every node you calculate your current so that you're able to size your cables. Okay, so the voltage here is 12. Okay, then the power that is flowing is about 40 watts. Okay, so the power is 40 watts. Okay, and then the voltage is 12. Now the voltage is 12. If you use this formula, this current equals to power over voltage, you have 40 over 12, which is equals to 3.33. You can see that the current that is flowing from this charger to the laptop is different from what is flowing from the socket to the charger. That is why you see your cable, you see your charger, your laptop charger. The cable size here is different from this cable. Have you ever noticed? Check your laptop charger, you see that the cable here is different from the one that is here. So anywhere you see cable in a solar system, please always do your current calculation. Okay, so this is 3.33, then this is 1.6. You can see that two different amps of current is flowing through the different sections, both sides. This part is for one section and this is another section. Okay, so wherever you see cable in a solar system, always use your cable sizing formula, which is current equals to power over voltage, and do your calculation so you're able to get your power. Okay, so that is for the charger analogy. Now let's go to our DC system. Anywhere you see cable, take note. Where there's a cable that is linking 2 points, the cable is linking this charger and current is drawn from here to here. Okay, you do your calculation. Whenever current is also drawn from here to here, you also do your calculation. When you see two systems or three separate sections that is transferring current between each other, you should use that power calculation, okay, that current formula calculation, and use it to apply it there, and you'll be able to get it. Okay, that is enough of this charger. Now let's go to our solar setup. Now if you have a system here, take note, I said if there's current flowing, if you have anywhere you see cable and current is flowing from one node to the other, please always do your calculation. Now let's use this. Let's say we go to our solar system completely. Okay, so let's go to our solar system now. Let's say we have an inverter here, and this is an inverter. Okay, then you have your PV plus and minus. This is how to connect an inverter. You have P, this is photovoltaic section. Then you have battery plus and minus. You have in, which is from the grid, in plus and minus, and you have out plus and minus. Okay, so let us draw our solar panel. Okay, so this is the solar panel here. Okay, that's the solar panel. Then our battery also. Let's draw a battery here. Let's say we are using a lithium battery. let's say we have a 5 kVA lithium battery, which is, let's say, 5,000 watts. Let's measure the battery in watts. Okay, so that's 5,000 watts. Then this panel here, let's say the panel here is let's say the panel is let's say 2,000 watts. 2,000 watts. This is a 2,000 watts panel. Okay, and then this is your load. This is the load to the house. This is load to the house. And generator, you know, your national grid, you can also charge your inverter, your battery with your NEPA light. Okay, so current is also flowing from there. Current is also flowing from the grid. Let's put the grid here. Let's say this is the grid here. Okay, so this is the national grid, this is your NEPA, and this is the load. So, okay, so let's do our connection. So our cable from the solar panel, it goes to the plus to this plus here, and the minus to the minus of the PV section. Then the battery, there should be a breaker. You know, there's one of our videos on this channel. You can start to watch the video and understand how solar panel is connected, how an inverter is connected. Okay, your hybrid. You can watch the video. It's on this channel how hybrid inverters are connected. Okay, it's there. Okay, then the input from the grid should be from here. Okay, this is to the grid. Then this to the grid. Okay, then our load. Let's connect our load here. The house, which is the load. Okay, plus and minus. Okay, now watch carefully. This is the grid. This is the load. This is the grid. That's the grid. This is the battery. And this is the solar panel. This is the inverter. Okay, now take note. If you see this inverter setup, current is flowing from the solar panel to the inverter. Look at it. Current is flowing. There's a cable here. So remember what I told you? I said wherever you see cable, whenever you find any cable at all, do your calculation. Okay. So there's cable from this solar panel to the inverter. So we are going to do our calculation here. Let's assume we don't know the cable size there. There's also a cable that runs from the battery to the inverter. So we're also going to do our calculation here. Take note. These are different sections, different nodes. We're also going to do our calculation here. We don't know the current to determine the cable. There's also a cable that links from this inverter output to load. Okay, the out is to load, while the input is from the grid. So the input is also grid. We don't know what the current that is flowing here. We don't also know the current that is flowing here. So we're going to calculate. We have 4 separate sections where current is flowing from one plot to another. Current is either flowing to the inverter or flowing out of the inverter. So we're going to calculate our current here. We're going to calculate our current here, and here. And we're able to size our cables because these cables are different. They are different cables. There was one installation I did. I went to correct the installation. The installer used 6 mm cable to connect a 10 kVA solar, 10 kVA battery. He used a 6 mm cable to connect a 10 kVA battery, which is very wrong. Okay, so that is fire. You are building a fire system. Okay, you are building a fire system. You are building a ticking time bomb. Okay, so that is the inverter. This is the inverter. This is the section, the grid, the load, and all that. Now what we're going to do, we're going to calculate the power. Let's start from the battery. Let's start from the battery. So the current is flowing from the battery to the inverter. Take note, the current is flowing from the battery to the inverter, but we don't know the amount of current that is flowing from here to the inverter. Now let's use this battery here. Is a 24 volts. 24 volts. Okay, this is 24 volts. It's written on the battery. You can check the nameplate. It's written on it. So the battery is a 24 volts battery with 5 kVA battery or 5,000 watts battery, 24 volts system. This is the battery. The current is flowing to this inverter, and this inverter is a 5 kVA inverter. 5 kVA. Let's say 5,000 watts. Let's say 5,000 watts inverter. Let's measure the inverter in watts so that you will understand. So current is flowing from this inverter, this battery, to the inverter. Current is flowing from the battery to the inverter. But we don't know the amount of current that is flowing because it is the amount of current that will determine the cable that we need to connect this battery to the inverter. Now let's use our formula. Power equals to current times voltage. You already know this. Then let's say current equals to power over voltage. The power here is 5,000 watts. Power is measured in watts, which is 5,000. The voltage is 24 volts, okay? So the volt that is flowing from here to the inverter. This inverter is a 24 volt system. So the voltage that is flowing to the inverter is 24 volt, okay? 24. So let us see the current now, which is 5,000 divided by 24 is 208 amps. Current is measured in amps. So the current that is flowing from this battery, can you imagine? From this battery to the inverter is 208 amps. So we're going to wipe all these ones off, wipe everything off, and write the 208 amps here, which is the current. So I'll teach you how to calculate how to know the rate of the size of cable. Let us write it's 208 amps that is flowing here, 208. Okay, we know this already. Good. Now we already know the current that is flowing from the battery to the inverter. Good. Let's talk about the panel. Now let's not talk about the panel. Let's go here. Let's talk about the grid. The grid system, which is your national grid, is 240 volts. We all know this 240 volts. Okay, so the grid is 240 volts, and it's a 5,000 watts inverter, so it's drawing 5,000 watts. So 5,000 watts from the grid, so that you can charge. It's using it to charge, so it needs 5,000 watts to be able to charge the battery. Okay, so this inverter is drawing 5,000 watts from this grid. Okay, it's drawing 5,000. So the power is, if you use that same formula, that's current equals to power over voltage. You have 5,000 watts. It is because it is drawing 5,000 watts from the system. 5,000 watts divided by voltage, which is 240. Okay, so the voltage from here for the national grid, you know, national grid voltage is 240. Your NEPA light, you can use your voltmeter to measure it, is 240. Okay, alternating current is 240. Okay, so 5,000 in my country is 240. I don't know what the voltage in your country. So 5,000 divided by 240 is 21 amps, approximately 21 amps. So 21 amp of current is flowing to the inverter from this section. 21 amp of current. Take note, 21 amp of current. Okay, so 21 amp is flowing from the grid, this cable here. So it's 21 amp that is flowing. 21. Good. That's from the grid. What about the load? So the output. This inverter is a 5,000 watts inverter. So it delivers 5,000 watts, delivering 5,000 watts of load to the house. Imagine you have your water heater here and you turn your electronics on, everything is 5,000 watts. So it will draw 5,000 watts from the inverter because you are sending the voltage out to the house. Okay, so let's say you put all your lights on, you turn your ceiling fan, your ACs and all that, it will draw 5,000 watts. Okay, so the maximum load is 5,000 watts. So the voltage, the power that is flowing here is also 5,000 watts because it is sending 5,000 watts to the house. Okay, you understand that? Very good. So 5,000 watts is flowing. We are going to use the same formula here again. We have calculated this already. So we're going to use that same formula for this part, which is power, which is current, equals to power over voltage. You already know the formula. So the power is 5,000 watts. So can you guess the voltage? What is the voltage that is flowing to the house? Can you guess? 240, because it is 240 volt that you are using in your house. 240 volts. You can use your voltmeter, as I said, to check it. Okay, you put it in your socket, your voltmeter, connect your voltmeter to your socket, and you see it is 240 volt or 230. Okay, so it's 240 volt that is flowing to the house. We know that. Okay, that 240 volts. So 5,000 divided by 240 is the same thing, which is 21 amp. Okay, so 5,000 divided by 240 is 21. So 21 amp is flowing to the house. Okay, so we already know the current here. We know the current here. And then we know the current here. Then the solar panel. This is the part that is very tricky. So that's why I decided to do the calculation last. So let's say you have one panel which is 2,000 watts. 2,000. This is 2,000 watts panel. Now you have 2,000 watts panel, just one panel. Now the voltage of that panel is written right on the nameplate of that panel. The voltage, it could be 20 volts or let's say 50 volts. Okay, it's written on the panel. Okay, so if you want to calculate the current that is flowing, even the current is written on the panel. You can check it. You see short circuit current, you see maximum current, and all that. Amps. It's written as amps. You see it, current is written there. So we just want to assume that we don't know the current that is flowing. Okay, so that is if you are calculating, if you are connecting more panels, you are connecting in series and connecting in parallel. Okay, so if you have one panel, the power, the formula is I equals to power over voltage, right? Good. So you have one panel, the power is 2000 watts, which is 2000 over the voltage, which is 50. Okay, so the current that is flowing here is 40 amps. Okay, which is 2000 over 50. Okay, which is a 40 amps. So 40 amps of current is flowing to the inverter. You understand? But what if you connect extra panel? What if you connect more panels? Now take note, this part is very tricky. I think I'm going to do a lecture on this. This is 40 amps flowing. Okay, this is for 2000 watts. What if you connect another panel? Let's say you connect another 2000 watts panel. Let's say you connect another 2000 watts panel to it. Now take note, the voltage, the amount of voltage that will be output from this panel is a determinant of the type of connection. If you are connecting in series, your voltage in series, the voltage increases, but in parallel it is the current that increases. That is too complex for you to assimilate. Let me say, okay, we're connecting in series. Let's say you're connecting another panel in series. Now how do you connect in series? How do you connect panels in series? You already know that. I'll do a lecture on that. I think I've done a lecture on that. Go and watch it. Okay, so this is the panel here. This is another panel. Let's say this is 2000 watts. 2000 watts, another 2000 watts panel. Okay, then this is plus and this is minus. So you connect the negative of this to this. The negative of this panel connects to the positive of this panel connects to negative of this. Okay, then you have one positive here and another extra negative. So you have plus and minus here. So these panels are connected in series because you are connecting them end to end. You understand what I'm trying to say? This your left hand will join to the right hand of the other panel and so on and so forth. That's how you connect it. Okay, so if you are connecting like this, using your hand, connecting your right hand to the other person and others, connecting in a straight line. If you are connecting, take note, the voltage, this is simple. I think you know this one already. The voltage will begin to increase. If the voltage here is 50 and you connect two panels in series, the voltage of this panel will add to this panel will become 100. Okay, so the voltage increases. But the current, if you have, let's say you have 10 amps here, 10 amps, I also have 10 amps in this panel, the total current will also be 10 amps at the end of the day. Okay, so take note, understand that. So it is the voltage that increases if you are connecting in a series. But if you are connecting in parallel, what is parallel connection? Parallel connection is simple. I don't want to make it very, I don't want to lecture to be very long. If you are connecting in parallel is, this is both arms, this is my two hand, I'll connect it to the two hand of the other panel. These are the cables. I am the solar panel. I'll connect my both hands to the panel. This is plus, this is minus, these are the cables here. I'll connect it to the hand like this. Let's say this is the panel here. We'll connect the cables here. This is plus. But notice this is minus and this is plus. Okay, so this is plus and this is minus. See, this is a simple method of connecting parallel. You connect this plus to plus, connect minus to minus. See, they are linked together. If you're going to connect another cable, you see connect again to plus. You can begin to add all the plus together, add all the pluses together, all the minus together. Minuses, add everything together. Okay, so that is the parallel. And then you just connect one cable to this, which is neutral, and connect this one cable to that one. Okay, that is it. Okay, so that's series. So if you are connecting the panel in parallel, the current increases. The current, if you have 10 amps here and 10 amps here, the current will be 20 amps, but the voltage will be static. If the voltage is 50 volts, it will be 50 volts to not move. Okay, so that is it. Okay, so let's calculate the current that is flowing through this cable now. Let's talk about the current that is flowing through this cable. Okay, so let's assume you're connecting in series a 2000 watts panel. 2000 watts panel. Okay, let's say the total power rating of the panel is 2000 watts, and the current is flowing. So power equals to 2000. Then the voltage is on the rating is here. It's written on the panel. It could be 50 volts. Okay, so if the voltage is 50 volts, then the current that is flowing should be current equals to power over voltage, which is equals to 2000 over 50, which is 40. Okay, what if you have a 5000 watts panel? A 5000 watts panel. So if you have a 5000 watts panel, the current will also change. So 5000 watts divided by 5000 watts divided by, let's say, 50 volts. Then you will have 100 amps. So the current 100 amps. Okay, so the current is 100 amps that is flowing. The current that is flowing to this, if it is a 5000 watts panel, 50 volts. If it is a 5000 watts panel and a 50 volt rating, then the current is equals to 100 amps. So 100 amps is flowing to the inverter from this panel. So what do you think? What size of cable do you think In reality, you cannot find 5,000 watts and 50 volts. We are just using this to do the calculation so that you will understand how it is. So 100 watts, 100 amp of current is flowing to the inverter. So what is the size of cable? We have done our calculation in all parts. So before you do any calculation, before you do any installation, draw the diagram like this, do your installation, okay? Draw the diagram like this and do your connection. Okay, connect it, then do the calculation, and then you go to the ampacity table. It's right here. That's the ampacity table. So that table gives a chart that shows you the cable sizes. It matches cable sizes to current rating. If, for instance, you have 10 amps, less than 10 amps, you can start to use 1.5 mm cable and all that. You can start to also add your safety factor, but that is it will make it complex. I don't want to do that now. So I want simplicity. So that is what I do. I love simplicity. So we have 100 amps here. So from the ampacity table, 100 amps of current, the cable sizes, you can check the capacity. You can go to my website. It's right there. The description is right in my bio. You can go there and check. You can just, if you want to download the ampacity table, it's right on my website. So you can download the ampacity table and use it to match your current with the appropriate cable sizes. Okay. So 100 amps is equals to, what is the amount of cable that can carry 100 amps? Okay, from the ampacity table, 100 amps, this is the ampacity table here. So from the ampacity table, if the current is between 71 to 93, you should use, from 71 to 93, you should use 25 mm. But if the current is 117, from 93 to 117 and to 147, you should use a 50 mm cable. So it is a 50 mm cable that we are going to use here. So it's a 50 mm cable. But in reality, it does not work. Most panels are, if you find a 5,000 watts panel, the voltage will also be increased so that it will reduce the size of the cable. Okay, so this is a 50 mm cable. So we are assuming, another assumption. I want you to understand it. In reality, you will find something different. Okay, your calculation will be different, the load and all that stuff. Maybe your inverter may not be a 5,000 watts inverter. I just want you to understand how it works. Okay, so we need a 50 mm cable here. Okay, then let's calculate this also. A 208 amp of current. That is a very high amp of current. What is the size of cable here? Let us also make reference to the ampacity table. So 208 from the ampacity table, this is right here. That's the ampacity table. Okay, you can download that ampacity table, keep it so that you can make reference to it later in your later installation. That's 208 amps. It says for 208 amps, okay, from 180 amp to 260 amps, you should use a 95 mm cable. So this space is 95 mm. 95. That's why you see most times. Have you ever noticed that your cable, the cable of your battery is always bigger than every other system? Have you ever noticed? The battery of the cable is very big, always very thick. You don't wonder, like, why is my big cable bent very thick? Why is the panel very tiny? Because of this calculation. So this 200, I will tell you that, okay, this 95 mm that you need. So you can just go to my website. There's a section there. Just enter the power and all that, so to give you the rating, all the calculation that you need. Okay, so that is a 95 mm cable. Okay, what about the national grid system? 21 amps and 21 amps. So the 21 amps is from the ampacity table. Okay, between 115.9 to 22 amps should be a 2.5 mm cable. Okay, 2.5 mm cable or 4 mm cable. Okay, you can either use a 2.5 mm cable or use your 4 mm cable. You can see the 4 mm cable. 4 mm. This one also 4 mm. Okay, cable is very small. 4 mm. Can you compare 4 mm to 95 mm? You can see that the difference is very large. You see, so if you make the mistake of using this, most solar installers, I went to do a kind of solar correction, and I saw this. If there's videos online, you see videos online where solar installers will use 4 mm. This 4 mm, after calculating this 4 mm here, they'll use this 4 mm to connect everything. Use it to connect the battery and all that. So imagine using 4 mm to connect a 208 amp battery. Now you are building up a fire system. You are not building, it's not a solar system, it is a fire system. Okay, so that is it. If you use it to connect, so the cable here is different from the cable here. So that's why I decided to inflate my figures. Okay, so the voltage and all that. So the voltage changes and all that. You'll be able to do your calculation. Okay, so we need a 4 mm cable for the load. We need a 4 mm cable for grid, a 50 mm cable for the solar, from the panel to the inverter, and a 95 mm cable for your battery. Okay, so this is a very simple cable sizing video. I want you to watch. If you have not subscribed, please click on the subscribe button, subscribe to my channel, so that you receive more solar videos, solar installation videos, practical theory and all that stuff. Okay, so I will simplify it because I so much believe in simplicity. So I love you, so I will see you in the next video.